Hello everyone. You may notice that I made some adjustments to the equations that I had in the corner, and they're a bit different from what we had in the last few videos. However, right now we're moving on to free fall. And what we dealt with last was motion in the horizontal direction. Now we're dealing with motion in the vertical direction and in free fall. Now, what is free fall? Free fall is when the only force acting on an object is the force of gravity. Of course, we're neglecting air resistance inside this case and drag. On those two may be the same thing, I'm not sure. Please let me know inside the comments. However, so I had to make the appropriate adjustment. So when you're in free fall, the only force acting on you is the force of gravity, and the acceleration due to gravity is negative g. And what does that negative g denote? That negative g denotes the direction. If we're taking down as negative and up as positive, this is saying that there's a constant acceleration due to gravity going downwards. And I just put the y's there so that we don't forget that we're dealing with motion in the vertical axis. So it's not entirely different. I just changed the axis that we were in. Before we were in the horizontal axis, now we're in the vertical axis and we're on the free fall. So you have to adjust the equations accordingly. And sometimes this is where some difficulty lies with students. It's making the necessary adjustment. There's a math component to it, but there's some essential understanding of physics so that you can adjust your math to fit the situation, okay? And here I just have it written plainly that acceleration in the y under free fall is equal to negative g, okay? So let's begin, let's knock out a problem and see if we can make some sense of this. So Bobby J wants to test out his new OtterBox case for his iPhone X or iPhone 10. After he drops it, it takes 3.25 seconds to hit the ground. Now, how high is the cliff? Okay? So first of all, let's assume that Bobby J drops this phone from rest. He doesn't give it any initial push. It's in his hand and he just drops it, okay? So we know that the initial velocity in the y is equal to 0. It's always good to start writing down everything you know, okay? So we know that gravity is negative 9.81 meters per second squared, and we know that the time it took is 3.25 seconds. And we could do some things, we could do this several ways, however, we want to do this in the most expedient manner possible, okay? And we want to find the height of the cliff, okay? And we can pick this to be our 0 point, and we can pick here to be our final height, or we could pick here to be our final height, or we could pick here to be our 0 point. But for the sake of this, I will just write delta y, which is equal to y minus y naught. That's what we're trying to find, okay? Now, straight from here, we have this to find, and we have 3 knowns, okay? Can we use this? We could use that, but that doesn't give us what we want right away. And we also could use this, but this requires a final velocity, and we don't know the final velocity. However, this equation right here, this has everything that we want, because this has initial velocity in the y, this has time, and it has gravity. And it so happens for us that explicitly it says y minus y naught, which is what we're interested in. The change in displacement is equal to exactly that. So we have my y minus y naught is equal to velocity in the y times time, which is just 0 times 3.25 minus 1/2 9.81 times 3.25 all squared, okay? Now, this top part is 0, and if we work out the bottom part, we have 1/2 times 9.81 times 3.25 squared. And our final answer is negative 0.81 meters. Now, you're probably wondering, why do we have this negative here? Remember, every quantity inside here is a vector quantity, except, of course, time. And we have the vertical displacement, the change in the vertical displacement, okay? So all this is telling us is that this object is going down because gravity is acting down, which is negative. So up is positive. So that's what this is telling us. This is telling us that our object is going down, which is consistent with our vector coordinates. Now, could this change? Yes, it absolutely could change. If I took up to be positive and I adjusted my equation accordingly, and not if I took up to be positive, if I took down to be positive, this would reflect that as well. So I hope this makes sense. And free fall, it's a very interesting topic. So just to reiterate, I've adjusted these kinematic equations for the purpose of free fall. And here we start off with what we do know, we write what we try to find, and from there we try to make physical sense of the situation. So we draw a diagram. Actually, it helps to draw a diagram first, just to make sure that you understand intuitively what's going on, because usually if you can picture it, it's a whole lot easier to solve the problem. So you draw it, you write down what you know, everything that you know, okay? And this is the part where you may have to make some fundamental assumptions, such as him dropping it with 0 initial velocity. That simplifies the situation. And you write what you do know, and first of all you try to figure out if there's an easy way to get to what you want, i.e. do you have an equation that has everything you need, okay? So we're going to continue to do a few more of these free fall problems, and again, if there's anything that you don't understand, something that I can do better, something I can explain better, or maybe a particular problem that may need some clarification, please do not hesitate to mention it. And again, congratulations. If you're here, if you're this far, you're doing an amazing job. That means you want to know, you want to do better, and you want to get a better grade or a better understanding of physics. So until we meet again,